Hi, I'm Vivekram Sivasalam and I am from a company called Continuum Blue. We are a certified COMSOL consultants. Today, I'm going to discuss how we at Continuum Blue use COMSOL to do modeling for automotive industries. To illustrate this, I'm going to show you how we perform thermal stress and fatigue analysis of a heat exchanger used on the railway. This is a CAD of a heat exchanger provided to us by one of our clients. As you can see, the design is very complex and it involves a number of components. And not to forget, there are hundreds of bolts present in the system. Once the CAD is built, we then use LiveLink for SolidWorks to import this CAD directly into our COMSOL interface, thereby making life easier. COMSOL also gives us a number of other features which can be used to edit the geometry built. For example, ignore edges and virtual operations are used to remove unwanted boundaries and edges. We then set up the parameters required, like geometry-related parameters or material-defining parameters inside the parameter section. We also use specific variable sections to specify variables needed to be solved for during the simulation. Selections and probes are also set to make things easier to set up the model. With so many components in this model, one can easily imagine the number of contact sets and the boundary conditions to be applied. Here is a list of contact pairs that we use. We also make use of identity pairs wherever necessary. Having so many components and each operating at different temperatures, the material characteristics are not easy to set up for thermal fatigue. Thanks to COMSOL, using the function feature inside the material section, we can make material characteristics to be temperature dependent. Having made the selections before and with the material parameter set, implementing the material properties for different components is made even simpler. Since we performed fatigue analysis of the system, we also have SN curves set up to help us analyze the fatigue life under various loads. Since the design of the system is very complex, the mesh is not going to be easier either. However, at Continuum Blue, we with our vast experience in meshing have meshed the system as best as possible. Here is what the mesh looks like. Coarse mesh has been used wherever possible to run the simulation quicker. As we perform a thermal stress analysis of the heat exchanger, we use the thermal stress physics already available in COMSOL. With so many components, setting up the boundary condition is a difficult task. However, COMSOL has provided us with some built-in features which make this look effortless. Depending on the client's requirements, a number of studies have also been set up. Here, 3 studies have been created: static for proof and thermal stress analysis, dynamic for fatigue analysis, and a time-dependent study for analyzing stress levels at different time points of the cycle. Predefined plots have been also set up based on the client's needs. Specific views are created so that the clients can visualize results depending on different material groups. Thanks to COMSOL once again, we use the export feature to export the images to set location while the results are plotted. All these things make the simulation so easy that not only do we provide accurate results, but also perform them faster, thereby reducing time and, most importantly, the cost to our clients. Thanks for listening to me. Once again, I'm Vivekram Sivasalam from Continuum Blue, and for any further questions, please feel free to contact us at info@continuum-blue.com.